Hi guys, welcome back to another Unity tutorial. My name is Devin, and today we're going to be going over how to make your GUI scalable across all screen displays. So no matter if you're developing for a small smartphone or a large HD TV, your GUI will still take up the same amount of screen space on all devices. No matter how many pixels are in the screen, no matter what the aspect ratio is, we're going to make the GUI fit on your screen. Now, there are a few ways to do this. I'm only going to focus on one, the way that I like to do it, but there are, many ways to do it. There are also plenty of GUI plugins, such as NGUI, a very popular Unity plugin. In this video, we're going to be just using the default Unity GUI, which, some point in the future they're going to update to be more like NGUI, but right now we don't have that, and people need to know how to make their GUI scalable now. So that's what we're going to do. Alright, so in my scene I've got three GUI elements. I've got this button right here, this long thing, and a square. That is my logo. Right now the GUI looks good, right? Yeah. Everything fits, it looks great. And right now I'm at 16 by 9, but there are many different aspect ratios that are used among monitors and mobile devices and such. The most common one for computers nowadays is 16 by 9, and all of these right here, 4 by 3, 16 by 10, 16 by 9, 5 by 3, 3 by 2, those are all possible mobile device screen aspect ratios, so you got kind of a wide variety. So my GUI works good on 16 by 9, but what if we were to use something like 5 by 3? Well, you may have noticed that there's a little bit of a gap, like increased gap in between these buttons, even more so if we do 3 by 2. But that's not a huge deal, right? Well, what if our screen was a little bit smaller? Or a little bit bigger? You're going to get some nasty gaps and some weird offsetting if you use Pixel Insets. And I'll explain what those are in a second. Actually, I'll explain that right now. Alright, so if you notice, all of my GUI textures have 0 scale in the X and Y. Just ignore the Z value for now. It doesn't matter right now because it's a 2D image. Actually, Z does matter for position to determine what stacks on top of the other thing. So if I look at my square, actually, if I look at my long thing right here, now I'm going to look at my button. Alright, so my button has 0 scale, which you may think, oh, well, it should not even be visible because it has 0 scale. Well, yeah, except for in our GUITexture component, we have this Pixel Inset value. And in here we can increase the X and Y. This is for position along the screen, and width and height. Now the thing with these Pixel Inset values is they are hard pixel values. So right now my GUITexture is set to be offset 300 pixels from the left of the screen in X. Well, alright, that might be fine for a mobile tablet where I might have 700 pixels across. It'll be right in the middle. But if I have like a phone, the phone is going to be much smaller. It may only have 300 pixels. It may only be 300 pixels across, in which case my GUITexture will be way over here, and that's no good. Likewise, if I have a gigantic HD TV, my GUITexture will all be in the little corner right here because there may be like 10,000 pixels this way, and I'm only insetting it by 300 pixels. So generally, I don't like to use the Pixel Insets at all. Also, you may have noticed that the button kind of gets pushed off the screen, but this square stays more or less in the center of the screen, but still gets cut off. And the reason for that is my square has 0.5 in the transform position. And actually, the transform, position, and scale are what I like to use for my GUI. So I'm going to just grab my long... I'm going to go ahead and grab my long thing and zero out the pixel inset. And I'm going to go ahead and hit 1 in X and let's say 0.1 in... or let's say 0.3 in Y. And then I'm going to go ahead and move the X and Y position. So all I'm doing is I'm moving the X and Y position and changing the X and Y scale on the transform component, not in the GUITexture. I'm just going to go ahead and ignore the GUITexture component completely for the rest of the tutorial. And I'll go ahead and explain what I'm doing here after I line it all up. Alright, so if I have a smaller screen or a larger screen, this GUITexture will always take 100% of the X pixels in the screen and 0.3 or 30% of the Y height of the screen. And this is the way that I like to work. The only problem you may notice is if you have a different, like a radically different aspect ratio, you're going to get a little bit of stretching. Like here you can see that's a little taller. And that'll be a problem with things like our square, or if you need something to be a perfect circle. But we're going to do a little bit of coding real soon to fix that. But for now, let me just explain what I just did. So this long thing, we're using 0 for all of the pixel insets, and we're only using these transform values. What the transform values are is they're a value between 0 and 1. 0 for X being all the way on the left, 1 being all the way on the right. So it's a normalized value, a value between 0 and 1. So 0.3 is 30% of the Y height of the screen, 0.2 is 20%, 0.1 is 10%, oops, and so on. So I'm just going to go ahead and zero out my pixel insets for the scale of the button now, and do the same thing. Move this guy over. Yeah, so pretty straightforward. Hopefully it makes sense. The individual GUI textures are anchored, their anchor point is in the center. So if I put this at 1 and 1, the very center of the GUITexture is going to go 100% of the screen in X and 100% of the screen in Y, and its center is going to be right there. Let's say you wanted the anchor to be on the left side of the screen. One way you could do that is create an empty game object. I'm just going to go ahead and duplicate this this object. I'm going to set its scale to 1 and 1. Actually, that's a bad idea. I'm going to set its scale to 0.05, 0.05, and then just try and get that kind of... Oh, right. So also, if you want to move something in front of another thing, just make sure that it has a higher Z value for position, so it'll show up on top. Let's go ahead and say that's the center. I'm going to go ahead and hide that. Yeah, so this will be our button anchor, and I'm just going to parent the... Well, actually, hang on. I'm going to set the scale back to 1 and 1. Just to keep things uniform, 1, 1, 1. It doesn't matter because you're not actually going to see this, but we're going to parent our button to this button anchor that we just created. And now, if we wanted to scale our button and have it scale from right to left, then we would grab the button anchor, the parent object that we just made, and scale that down slightly, and it will scale from the left. Yeah, so that's how you would make another anchor point. So you could use this for, you know, health bars or an energy bar or experience bar, anything that you need to drink or grow from a specific anchor point. Alright, so now let's get into our square. Alright, so if I zero all those out like we did for the others, and let's say 0.3, 0.3, well, it's not going to be a perfect square because our aspect ratio is not going to be a perfect square. So we could kind of guess and say, alright, that looks like a square. But then again, if you change to a different aspect ratio, it's going to get stretched again, and then it won't look like a square. So the way that we're going to fix this is we're going to have to do a little bit of coding magic. Now I already have a script written. I'm just going to go ahead and throw it onto my GUITexture. And you can see right now I have a vector 2, and that is scale on ratio 1. What that means is, what do you want the scale to be if the aspect ratio were 1, meaning if it was 3 by 3 or anything where it's a total square screen. So we decided that 0.3 looked good, right? So let's say we want it to be 0.3, 0.3. And now if I play the game, it will automatically shrink to be a perfect square. And, you know, if my screen size is smaller or bigger, it will still be that perfect square and it won't get cropped out. Let's see if we change our aspect ratio. It resizes itself to be a perfect square again. So, yeah, you could either write scripts like this or use a combination of pixel insets and transform positions and scales to try and get the look that you want. Or you can do what I do and just zero out the pixel insets, don't even use them, and only work with the normalized screen space values for transform. Alright, so let's go ahead and take a look at how this script works. Alright, so in the script I have a little header up here that tells you how to use the script and all the possible aspect ratios for mobile. So here you can see we have our scale on ratio 1, which is a new vector 1 or vector 2, and that's the public variable that we input our desired size in. And then at the beginning I just cache our transform so I don't have to look it up again, and a private float value, which is width to height ratio, or width height ratio. It's going to divide the screen.width by the screen.height. So in this case 5 by 3, it's going to divide 5 by 3. Well, not exactly 5 and 3 because there's more than 5 pixels in our screen. But you know what I mean. That's the aspect ratio, so it finds the aspect ratio, and then we simply just scale our GUITexture. I scale our GUITexture's Y value by the width height ratio, and we don't touch the X value at all. Now the reason why we do this is we're getting our width to height ratio, so that's width over height. If our scale is 1, then we would need width over width, and that would be 1, or height over height to be 1. But since we have width on top, to cancel this out, we would do something like we would multiply the height by this ratio to get just the width. So let's say this is 5 and this is 3, just like our aspect ratio up here. So if we take 5 and divide it by 3, and then multiply it by 3, we get 5, which would be our perfect square, or our aspect ratio of 1, which is what we're looking for up here. But we don't want it to be a perfect square. Well, in this case we do, but say we didn't. We want it to be a rectangle, a 2 by 1 for some reason. Then we would input our different values in here, and then this value will replace this value and give us our perfect 1 by 2 GUITexture. So just to show you that we can do that, I'm going to go ahead and make this 6. So it'll be a 1 by 2, or 3 by 6. And if I change our aspect ratio, it will always be 2 times taller than it is wide. But that looks a little weird, so I'm gonna go ahead and set this back to 3. Also, you notice that it updated every time I changed this while the game was running. We don't really need to do that. That's kind of a waste, and you'll notice that I have this to do up here, which is delete the update part. So I'm just going to go ahead and do that, And the reason why we don't want to call this onUpdate is because when our game starts, it's generally not going to change aspect ratios, so we don't need to change the aspect ratio every frame. We only need to do it on startup. Or, if you have an options menu in your game where the player can change their screen resolution, then you're going to want to call this function again on all of your GUI textures just to make sure that they are all set up the way that you want for that aspect ratio. Alright, well that's it. Thanks for watching this quick tutorial on how to make your GUI textures scalable across all screen aspect ratios and sizes. I hope it was helpful. Be sure to like and subscribe if it was. And don't forget, you could always download this code that we used in the tutorial and all of my previous tutorials on my website, devination.com. Don't forget, you could also follow me on Twitter, Facebook. I've also started a Google Plus community recently where you can go to just ask questions or say hello or show off something awesome that you made in Unity. So yeah, thanks again for watching. I'll see you next time.